In this video, we'll look at a question on dimensional analysis. A ball of mass m is thrown vertically upwards with initial velocity u. When the velocity of the ball is v, it experiences a force lambda v squared due to air resistance, where lambda is a constant. Now we are expected to find the dimensions of lambda. Now this is the first part of the question. We have a second part of the question where a formula approximating the greatest height that the ball can reach is given here, and we are expected to determine whether the formula is dimensionally correct. Now the last part of the question, that a better approximation of the formula has been given over here, and we are asked to use dimensional analysis to determine alpha, beta, and gamma. Now, the concept in physics behind this question is free fall motion, where the body, as it were, is mainly under the force of gravity, pulling the body towards the earth. Other forces may be involved, or other forces may exert their influences on the ball, but they are not too significant when it comes to free fall motion. However, in this question, the ball experiences a force lambda v squared due to air resistance. And so the influence of air resistance here is considered. Free fall motion is not our focus in this video. So let's consider the dimensional analysis aspect of the question and determine the dimensions of lambda. So let's go ahead with a solution. The force is given as lambda v squared, and so lambda can be rewritten as, so in order to determine the dimensions of lambda, we would need the dimensions of the quantity force and that of velocity. So what is the dimensions of force and what is the dimensions of velocity? According to Newton's second law of motion, the force is equal to the mass of the body and its acceleration. Now let's familiarize ourselves with the dimensions of a few quantities. The dimensions of mass, the dimensions of displacement, and here I'd like to keep the dimensions of the quantities in their MLT format, the dimensions of time, velocity, and by that, the velocity squared will be given by acceleration so the dimensions of force will be that of mass and that of acceleration. So the dimensions of force applying the properties of indices, we're going to get so with this, we're going to plug in the dimensions of force and the dimensions of v squared in the formula given here in order to arrive at the dimensions of lambda. So the dimensions of lambda is given by so this is the dimensions of lambda, and that is the answer to the first part of the question. In the second part of the question, we are asked to determine whether the formula given here is dimensionally correct. So let's copy this question down. Let's copy this question down. And we are asked to determine whether this equation is dimensionally correct. What that means is that we're going to write the dimensions of the quantities on the left side of the equation and do same for quantities on the right side of the equation and compare their dimensions. And when the dimensions satisfy the principle of homogeneity, then we can go ahead to say that the equation is dimensionally correct. So we'll go ahead to determine what is the dimension for height, and what is the dimension for this whole expression here, and what is the dimensions of this whole expression here simplified. So we'll go ahead with that. The dimensions for height is given by that of the initial velocity is given by u squared will then be given by so u exponent 4 would also go by so with these dimensions we will go ahead to simplify the dimensions for the first term, this u squared divided by 2j, and then lambda u exponent 4 divided by 4mj squared. Now we have the dimensions of lambda over here, so we'll go ahead. So with the dimensions of u squared G is the acceleration due to gravity, and it has the same dimensions over here. So we're going to have so when we are to simplify, so that is the dimensions of this first term over here. So let's simplify the dimensions of this expression here. Now, lambda is given by u exponent 4 is given by this expression over here. Dimensions of mass is and the dimensions of g squared is given by let's not forget. And so simplified, we're going to get so it will be simplified to get so the dimensions of this expression over here has been simplified into this form. Now let's go ahead and plug in the dimensions. Each has a dimension of and the dimensions of this expression is given by now let's simplify. So at this point of the solution, we can now compare the left side of the equation to the right side of the equation. And we can easily observe that the dimensions to the left side of the equation is the same as the dimensions to the right side of the equation. In comparing the dimensions, dimensionless constants and dimensionless quantities are not taken into account. So from here, we can safely say that the equation as we have here is dimensionally correct. So we can conclude by saying that the equation is dimensionally correct. So let's go to the last part. Now, a better approximation of the equation has been given over here, and we are supposed to use dimensional analysis to determine alpha, beta, and gamma. So let's go ahead and copy this entire equation down there and write it here. Of course, this is the third part of the equation. So we have now the dimensions of this part of the equation has already been determined in the second part of the question. So we are going to go ahead and replace that dimensions over there in order to simplify the solution of the third part of the equation. The dimensions of height now, the dimensions of lambda has been determined in the first part of the equation as let's not forget the exponent. The dimensions of the initial velocity u has also been determined as the exponent. The dimensions of mass, the exponent, and the dimensions of acceleration due to gravity, the exponents. Now, let's take this part of the equation to the left side And when we so do, we're going to have now applying the laws of indices, the respective exponents are going to apply to each of the base dimensions within the square bracket. And so we're going to have this. Now here we're going to have and still applying the laws of indices, the products law. We're going to identify their respective base dimensions and their exponents and add them. So when we take the base dimension of mass, we have 2 here, we have beta here. And so we're going to have the base dimension of length, we have -2 here, we have alpha, and we have gamma. Then for the base dimension of time, we have minus alpha and -2 gamma. Now, in comparing the base dimensions on the left side of the equation to the right side of the equation, we can come to the conclusion that with the base dimension of mass, with the base dimension of length, we can come to the conclusion and have this equation comparing the exponents that and comparing the exponents of the base dimension time, we can say that now from here we can conclude that beta is equal to -2, then alpha and gamma is equal to 3, and from here we can say that alpha is equal to -2 gamma. Now let's substitute alpha as -2 gamma into this equation and say that so it means that gamma is -3. And from here, we can conclude by saying alpha is 6. So it means that alpha is 6, beta is -2, and gamma is -3. So with these values, we can conclude that the equation is giving us in other words, the maximum height that the object can reach is given by the formula So the values of alpha, beta, and gamma are 6, -2, and -3. And the equation that we seek to determine is given by this expression over here. So that is the end of my video. Thank you very much for watching, but keep watching.